What's up, algebra students? Let's do this. We're on 9-3, and this is a really cool lesson. Solving quadratic equations using square roots. And the essential question is, how can I use square roots to solve equations? It's a boring, essential question, but it's really what this section's about, solve equations. I'm just going to put EQ period and the question mark. Okay, let's jump right in. It's not that hard, but it just takes some getting used to. Okay, what's a solution? When we read that word, we want to make sure we know that that is the value of the variable x that's going to make this equation true. D is going to be a constant. So if D is greater than 0, that means D is positive, right? There are two different numbers you can square to get D. Just to illustrate this, imagine D was 4, right? What values of x would make this equation true? Well, 2 squared is 4, but quantity -2 squared is also 4 because -2 times -2 is 4. So anytime D is positive, there are two solutions. That's why it says when D is positive, there are two real solutions, and they are positive and negative square root of D. Sometimes you can, sometimes D will be a perfect square, and sometimes it won't be, and we'll talk about what to do when it isn't. If D is equal to 0, well, let's see, what's the only number that can be squared to get 0? Well, there's only one number, one real solution, and that's x equals 0. If D is negative, is there any number you can square to get a negative number? No, so there are no real solutions, right? So now let's take a look at some examples. This says to solve 3x squared minus 27 equals 0. Well, our goal is right now is to get it into this algebraic form. So the x squared is by itself. Well, x squared is definitely not by itself. It's got a times 3 and a minus 21. So what are we going to do first? Well, do we undo multiplication first or subtraction first? Usually subtraction. So we add 27 to both sides. Because I have limited space, I'm not going to show that step, but of course I did add 27 to both sides using the addition property of equality, then I get this. Now I'm going to divide both sides by 3 using the division property of equality, and I get x squared equals 9. And here's the trick. There is essentially a kind of square root property of equality. To find the value of just x, I'm going to take the square root of both sides of this equation now that it's in the form x squared equals d. When you do that, and I'm kind of moving sideways here, I'm sorry, this is not very clean, x is going to end up equaling positive 3, right? Because 3 squared is 9, and square root of positive 9 is 3. But it's also equal to -3. And we have to include that -3 because if you take -3 and you square it, you also get positive 9. So those are our two solutions. And that should have two solutions because it's this first scenario here, where if D is greater than 0, it was, 9 is greater than 0, there should be two real solutions. Okay, what about this one? First thing we got to do, and I think I could be a little cleaner this time, add 10 to both sides using the addition property of equality. Why? We want to get the x squared by itself. We just did. With x squared equals 0, now I'm going to take the square root of both sides. Well, the square root of x squared is x. What's the square root of 0? 0. And just like the second part of the algebra here, if D is equal to 0, then there is only one solution, and that's x equals 0. And I know, I didn't highlight. I wasn't being consistent here. There you go. For all of you who really wanted to see that happen, you're welcome. Okay, here, I'm going to subtract 11 from both sides, and then I'm going to get negative 5x squared. So using the subtraction property of equality, negative 5x squared equals, and then 16 minus 11 is 5. I divide both sides by -5. I get x squared is equal to -1. I take the square root of both sides, and can I take the square root of a negative? No, it's this scenario right here. So there are no solutions, or no solution at all. I'm just going to do singular, no solution. Ayabuka. And there it is. So beautiful. Look at that. All right. Hopefully your work looks better than mine. We're moving on to the next one. Let's just keep on going. This is so much fun, you guys. You have to understand, like, I just love being able to spend this time together. Okay, here it says, with equations, we've learned that as long as we do the same on both same operation on both sides, that means on the left and the right side of the equal sign, the values on each side remain equal. We know that from way back in our days in Math 6 Accelerated, where if you had 5 equals 5, if you add 3 to both sides, you get 8 equals 8. Okay, besides the 4 operations that can be used to keep both sides of the equation balanced, we can also take the same root on both sides. Here's an example. 25 equals 25. Now let's say we take the square root of both sides, and we get, well, this is actually a little bit misleading. I think that you should write this as, it could be 5 equals 5, or it could be negative 5 equals 5, right? Even though generally, when you're showing the radical like this, we take what we call the principal square root. We would only take the positive one. But in the context of solving equations, that means finding the value of x, we're going to want to take both the roots when we do this. Okay, so here we go. The quantity x minus 1 squared equals 25. I can't add 1 to both sides using the addition property of equality to get rid of this minus 1. I could add 1 to both sides, but it would just make things more complicated because I end up with 2 terms over here. I'd end up with quantity x minus 1 squared plus 1. We don't want that. But I can I square root this? And the answer is yes, but on the left side, yeah, sure, you do. You get x minus 1, right? Because instead of quantity x minus 1 squared, it's now just x minus 1. But when you square this right side, you get 2 roots. You get x minus 1 equals 5, and you get x minus 1 equals negative 5. So the fact is that over here, we said we take the principal square root, we only take the positive one. But when we're solving equations, you have to take both roots. So now we have 2 different equations. So this is like the algebra that's up there on the top left, where you have basically d is greater than 0. So we should get 2 solutions, and we're going to get 2 solutions. I'm going to add 1 to both sides using the addition property of equality here. Add 1 to both sides using the addition property of equality here, and I get negative 4. Okay, because negative 5 plus 1 is negative 4. So that means both 6 and negative 4 make this true. Go ahead, try it. Negative 4 minus 1 is negative 5. Quantity negative 5 squared is 25. 6 minus 1 is 5. Squared is 25. So these are my 2 solutions. I should have expected 2 solutions. There they are. So beautiful. Okay, this one. What do we do first? Well, we want that x squared to be by itself, don't you know? And you don't want to use the division property of equality, because otherwise you'd have to divide this by 4, ew, 13/4, bleh, and 15/4. Bleh. Why don't we first add 13 to both sides? And we're going to get 28 over here. Much nicer. Divide both sides by 4. This is really starting to be amazing. And you get x equals 7, right? Wait, what am I talking about? X squared equals 7. Careful, guys. Don't forget stuff when you write the next line like I just did. Okay, now I square root both sides. Well, this is a positive number. I should get 2 roots. I'm not going to have you actually calculate what those are. You could type the square root of 7 into your calculator, and you'd get something between 2 and 3, because 2 squared is 4, 3 squared is 9, so it's somewhere between 2 and 3, probably closer to 3. Or is closer to 3. So what I'm going to write here, and this is something you may not have seen before, is that x is equal to positive or negative square root of 7. That's writing this as one statement, but what does that actually mean? It actually means this. X equals the positive root 7 and x equals the negative root 7. Okay, so what I've written here, these two different statements can be combined into just this one statement right here. And either way you write it, I would accept it. So on a test, you wrote x equals positive root 7 and x equals negative root 7, 100%. If you wrote x equals positive negative root 7, 100%. All right, let's just keep going. We're going so good. We're going so fast. We are. I actually don't know how fast we're going, but I think we're going quickly. Oh, what's going on right now? This thing's being really, really weird. Hold on one second. There we go. It just took a minute to load. Nothing but the best tools, guys. Nothing but the best tools. Okay.